Myth number 3, titanium's perceived ability to absorb vibration. Let's begin by defining vibration. The Encyclopedia Britannica defines vibration as periodic back and forth motion of the particles of an elastic body or medium, commonly resulting when almost any physical system is displaced from its equilibrium condition and allowed to respond to the forces that tend to restore equilibrium. Whew. Let's try to put this into terms we can all understand. In wheelchairs, this is comparable to the effect of pushing over rough surfaces, which creates vibrations. What is vibration absorption, or more accurately, dampening? The same Encyclopedia Britannica describes dampening as, in physics, the restraint of vibratory motion such as mechanical oscillations by dissipating energy. In less complex terms, dampening is the speed at which a vibration fades away. A long-lasting vibration has a lower loss factor, or dampens more slowly. A vibration that ends quickly has a high loss factor, or dampens faster. From a wheelchair user's perspective, better dampening or a higher loss factor means a smoother ride. Consider the independent literature review, Comparison of Damping Characteristics of Structural Aluminum and Titanium Alloys for Wheelchair Frame Applications. According to this thoroughly researched review of titanium and aluminum alloys actually dampen better than titanium alloys. Aluminum has a higher loss factor. To understand this difference, let's strike a tube of aluminum. A high loss factor will dissipate the energy quickly. A low loss factor will allow the vibration to continue, as is evident in this example. Now let's try a titanium tube of equal length struck with equal force. As you can see, the difference between aluminum and titanium is almost imperceptible. Now, let's compare these tubes to a high-density polyethylene plastic. In this case, there really is a big difference between the 0.006 average loss factor of the two alloys versus the 0.9 loss factor in the plastic. Plastic is obviously our dampening champion. Consider other common materials found in wheelchairs and seating products. A piece of rubber from the caster wheel has a loss factor in the range of 0.1. Seat padding foam can be as high as 5. This means the material in a seat cushion can have a dampening capacity that is 500 to 2,500 times greater than either titanium or aluminum. In other words, from an overall material standpoint, titanium and aluminum barely dampen at all. To summarize, any statement that titanium as a material dampens vibration better than aluminum in wheelchairs is incorrect for two reasons. One, from a purely material standpoint, aluminum alloys used in wheelchairs actually dampen vibration better than titanium alloys. Two, the relative amount of dampening by either aluminum or titanium is insignificant compared to other elements within the chair. A wheelchair's ability to dampen vibration and provide a smoother ride is a function of the overall design of the entire system, not one single material. To look at it any other way is simply a myth.